When I like a song and want to keep listening to it, I click the option Repeat. By doing that, I avoid keeping pressing the play button every time the song finishes, as the player starts playing it again from the beginning. Python allows you to repeat a code block to run many times without pressing the play button again. The option of repetition is known as loops. Loops allow you to repeat a code block, or also called iterate the code block, without you going back and rerun it. Python has two kinds of loops: for loops and while loops. Let's discuss for loop first. A for loop is used to iterate or do something repeatedly over an iterable. Now, what is iterable? The iterable is a thing, an object that can return one of its element at a time. For example, list is an object. Even the word hello, which consists HELLO, is an object. The object could be a sequence type such as a list, a string, or tuple. Tuple is a data structure that we didn't discuss in this course. And also non-sequence type such as dictionaries and files. Make sure you understand the difference between sequence type and non-sequence type. In the previous lecture on list, we discussed that the list use integers as indices to access the values they contain. It is a sequence type. On the other hand, dictionary is a non-sequence type, as it doesn't need integers as indices to access the values. It needs keys to access or map its values. For example, a list with many elements, as in this case, has a product cost list, and each number here is an element of the list. So the loop will pick one element number at a time and perform some operations defined in the block of code, once for each element in the list. Suppose your task is to create a price list of all these products, and the formula for calculating the price is cost plus 20%. So when you apply loop, it will pick the first number and adds 20% and save it in another list name product price. Then it will go back and repeat the same process on the second number, then third, and so on until it finishes all the numbers available in the list. Let's see how to code this process. I have created or initialized an empty product price list, which we will fill using for loop. The for keyword signals Python that we are starting a for loop. The product cost list is iterable, and I is the iteration variable that temporarily saves an element. You can name this I with any name you like: cost, B, Y, Z, anything. Once an element is saved in I, the code uses this variable here and adds a profit markup of 20% to arrive at a selling price. After that, we are adding this number using the append method to product price list. Append is another list method we use to add elements to the end of an existing list. In plain English, the first line says Python use for loop to pick the first element from the product cost list and temporarily save it in I, do some calculation that adds 20% in I. After this calculation, save the final number into another list name, product price. When the first element is done, go for the second number and do the same. And once the second number is done, do it repeatedly for all numbers in the list. As there are 13 numbers in this list, the loop repeats itself 13 times. 13 finite times. Let's run this code which does all this calculation and save product price in new list. And now let's run this to see the saved results. And there are our product selling prices, which is calculated in a fraction of a second. In the example above, the for loop repeated 13 times because there were only 13 elements available in the product cost list. For loops are an example of definite iterations, meaning that the loop's body is run a predefined number of times. In our example, 13 times. I am emphasizing the words predetermined and finite. This differs from indefinite iteration, when a loop repeats an unknown numbers of time and ends when some condition is met, which happens in a while loop. So the fundamental difference between for loop and while loop is a predefined number of repetition and a condition to check. If the condition results in false, it stops the loop. If the value of the test condition never changes, it keeps repeating the infinite number of times and result in crashing the program or hang the computer. So be careful to include a condition in the while loop. Let's see it in action. Suppose you are investing $10,000 in a bank deposit, which earn an interest of 5% per annum. You aim to withdraw this deposit once it's over 20,000, but you don't know how long it is going to take this initial deposit to reach the target of 20,000. So if you had to do it manually, this is one way of doing it using Excel. The initial deposit times rate is the interest amount. Interest amount plus initial deposit is the year-end balance. This year-end balance becomes balance at the start of the following year, and we repeat the same calculations for many years until we see our desired balance, which is now 20,789 at the end of year 15. And now let's see how while loop is going to achieve the same results much quicker. The code will look like this. In this cell, we give all the information we already know: the target of 20,000, the balance of 10,000, the rate of 5%, and what we want to know is when the balance will be over 20,000. So we initialize it with the 0 value. This number will increase for every additional calculation year until we reach the target. Lastly, I want to know the amount of interest we earned in the target balance. The first line starts with the while keyword, indicating this is a while loop. Following that is a condition to be checked. In this example, whether the balance is less than the target value. This is true at this stage, as the balance of 10,000 is less than the target value of 20,000. The while loop heading always ends with a colon. Indented after this heading is the body of while loop. If the condition for the while loop is true, the code lines in the loop's body will be executed. In this block of code, we calculate the interest amount and then add the interest amount into the balance to arrive at year-end balance. I'm using the same variable name balance for the initial deposit and subsequent interest addition for simplicity. I'm increasing the year variable by 1, indicating that the calculation is done for this year. So it will keep adding 1 to increase the numbers of years for every following year. This code block will change 3 variables after every iteration: interest, balance, and year. Once the first year is done, we then go back to the while heading line and the condition is evaluated or rechecked. as 1 year interest is not enough to bring the balance to the target value, the condition still holds true. So the code will perform its calculation again. This process of checking the condition and then executing the loop repeats until condition becomes false. That is when balance is more than the target. And this is where the loop stops. When the condition becomes false, we move on to the line following the body of the loop, which will be unindented. In this case, print year, which means we are out of the loop code block. Please remember, the indented body of the loop should modify at least one variable in the test condition. If the value of the test condition never changes, the result is an infinite loop. In our example, the loop body increased the value of balance variable until it becomes higher than the target value and resulted in the test condition being false. Now let's run the loop and see the result. First, the number of years, 15 years. Exactly the same number of years as we checked in our manual calculation in Excel. Let's check the amount of interest earned and balance after 15 years. Roughly 986 for interest and 20,789 total balance. Again, exactly the same. Now that you are familiar with both for and while loops, let's consider when it is most helpful to use each of them. For loops are ideal when the number of iterations is known or finite. Example, when you have iterable collection, list, string, set, tuple, dictionary, and the code like for I in product cost. While loops are ideal when the iterations need to continue until a condition is met. Example, when you want to use comparison operator, while count less than equal to 1000. This lecture concludes the first part of this series, where I aim to introduce basic programming concept to accounting professionals. Congratulations to come that far. It was not easy for someone with a business and accounting background. To me, it is a 360-degree change in the way of thinking.